Hello and welcome to the Geographic Calculator webinar for the month of September. Currently, all attendees are in a listen-only mode and you should be able to see our first slide on screen. I'm Taya Youngs, an application specialist for Blue Marble Geographics, and I'm here with Sam Knight, the Director of Product Management.
Good morning, everyone. Today's session is going to be a feature overview of the Geographic Calculator version 2014. We're going to be taking an overview of the new features to this year's version, and we're also going to be taking a look at the general features. So we're going to be taking a look at some of the older features, some of the newer features, just as a way of getting everybody up to speed.
If you have any questions during the presentation, you can use the questions tool on the GoToWebinar panel on the right of your screen. We'll try to answer your questions as they're submitted, and Sam will address any outstanding questions at the end of the presentation. We also have some upcoming conferences. Today, we're at EURISA GIS Pro, and you can see one of our support representatives, Jasmine, there this afternoon. On September 22nd, we have Gecko in the Rockies at Grand Junction, Colorado. You can see these at our events page here on the slide. And coming up on October 27th, we have a training in Houston, Texas for Applied Geodesy and the Geographic Calculator.
Okay, and on that events page, we also have many more events that will be coming up in the coming months, particularly October. September and October are always very busy months for us here at Blue Marble Geographics. And additionally, we have actually a couple of more special events that we want to bring attention to. One is already completed. On Monday, we had a Blue Marble User Conference up in Calgary. So thank you to everybody that came out. It was a great session, a lot of good speakers, a lot of good sharing of information. Coming up at the end of October down in Houston, Texas, we're going to be having another one. So another Blue Marble User Conference. This is the first time we've been able to do two conferences in 1 year. The second conference is going to be on Thursday, October 30th. That's going to be at the Royal Sonesta Hotel it's in the Galleria District in Houston. That's coinciding with the GETA Pipeline conference that happens there annually. And that is around the same period of time we're going to be having our Geographic Calculator and Global Mapper training. So check out our website for more information on the upcoming user conference and the training opportunities that are going to be available in Houston. So today, what we're going to do is get right into the software. And we're just going to start off with a quick poll, since today is a bit of a general overview. We're going to start off by just finding out how long you've been using the Geographic Calculator. So I'm going to quick launch this poll. You should see a multiple choice coming up on screen. And if you could just take a look at that, give us a quick idea of who's with us today. I'm going to leave this open for just a few more seconds. Looks like it's slowing down just a bit. And 5, 4, 3, 2, and we're going to close that up. Looks like we have a pretty good mix here today. I'm just going to put the results of that back up on screen. So a very heavy contingent of folks just getting started with the calculator, and that's great. That's really sort of what we're going to be targeting today in the presentation. Hopefully we're going to have some stuff in here for the folks that are in the middle there, the 1 to 2, and well, we'll just call it the 1 to 10 year band. And always good to see some longtime users there. Over 20 years now we've been around, and so it's really great to be able to say that we've had users using our tools for that long. So let's go ahead and close out that poll. And as always, as we're going along here, feel free to use the questions panel to send in any questions on any of the topics that we're seeing. We're going to try and handle them as we go today. So over in the Geographic Calculator, you'll notice in the title bar of my application, today I am running on the 64-bit version of 2014. Specifically, I have the latest Service Pack update. That's Service Pack 1. We rolled that out last month, a couple months ago now. All of the functions that we're going to take a look at today are mirrored in the 64-bit and 32-bit version. So there's going to be no difference on anything we see there. The two versions of the software are almost completely identical. There are just a couple of differences, mainly relating to spatial database connections, where the two versions of the application differ a little bit. So today, by way of introduction for the calculator, what we're going to do is take a look at some of the jobs and projects that I have defined over on the left-hand side of the screen in the Project Manager. The Project Manager is where we organize all of the individual either conversion tasks or calculations, whatever we happen to be doing with the calculator. When you first start it up, you're going to see essentially just this first folder at the top called Project. And that has empty jobs, and they're essentially just placeholders that will help you just have a visual indicator of where you're going to start. That really is just a jumping off point. And so we have several different types of base jobs, and they can be applied to many, many different scenarios and data conversions, different types of calculations. So it's a matter of adding the right jobs into your project folders, which are simply organizational folders. So you'll see I've got a couple folders here, some things that are new in the 2014 version, and a folder called Special Features at the bottom. Now these two folders at the bottom are really just extra groupings of things that I've put in place in my workspace for demonstration purposes. And for those of you who have been around a little while, seen a few of our webinars, you're probably seeing a lot of the same stuff in that thing. So what I've got here really is a collection of templates that allow me to very quickly go back to a certain type of data conversion. So we're gonna be mixing up here a little bit of some of the new features and some of the core features. First, I just want to take a very, very quick overview of what the base functions are, and then we'll get into some of the specialty tools that we've introduced in 2014 and how we've changed some of those things around at the service pack that came out this summer. So I'm going to start up here on the left-hand side in the Project Manager in my very top project, which is our default collection here. Now, the only thing different between mine is that I've already loaded some data in just for examples in each of these jobs. But the quick rundown on this is the interactive conversion job. So that's the job I just selected there. This is the collection of settings you see on the main part of the screen. And what this is a single point calculation tool. So this is for individual numeric coordinates, and there's a few different types of calculations that we can do on here. The most common thing that folks are using the geographic calculator for is conversion or transformation between coordinate systems. Down at the bottom left of this interface, you'll see there are a couple other calculations that can apply there as well. The forward and the inverse calculation. Those are distance and azimuth calculations across the surface of a datum. Forward is a slightly different interface. If we toggle over to that, you'll see the interface changes. The datum transformation box goes away, and we get some distance and azimuth boxes in the middle. These are for supplying a starting point and a distance and azimuth and calculation of an ending point. So it's essentially calculating the endpoint of a traverse away from a start point. The inverse calculation uses the same variables, essentially, except the input is different. So we're going to input a start point and an end point, and the calculation produces for us the distance and azimuth between those points. So it's the same math, it's just different ways of going through it. We're going to focus primarily on conversion-related tasks. That is the most commonly used set of tools throughout the geographic calculator. So here on the main interface, you'll notice there are a few standard pieces of the interface. There are the coordinate system settings for input and output, and the coordinate transformation box in the center. You're going to see that on just about every interface in the calculator. These boxes will allow access by double-clicking on any of them into the database of coordinate systems, coordinate transformations, units, all of those different geodetic parameters that we're going to be basing our calculations on throughout the calculator. Because I've already have some coordinate systems selected, it's going to bring me back to the folders where those are stored. So the general breakdown here is that we organize things by major categories and then geographically. So you'll see there are some top-level categories, fitted systems, which are engineering grids or local survey grids, geocentric systems, which are commonly known as Earth-centered, Earth-fixed, or 3D Cartesian. Geodetic is all of our latitude-longitude systems, sometimes called geographic. And projected are all of our things like transverse Mercator, Land conformal conic, your typical two-dimensional map projections, and a newer category down at the very bottom. We're going to be talking about this category a little bit later on in relation to one of the newer jobs in Calculator 2014. String coordinate systems are coordinate systems that typically follow either a projection or a latitude-longitude base for the system, but the coordinates are formatted very specially, and they typically involve breaking them down into zones. They're sometimes used for survey systems, local land survey systems, such as the Alberta Township System, various uses, things like British National Grid, and so on. So these are major categories of coordinate systems, and we then expand into geopolitical division, finding where these particular parameters live. So if I'm looking for the coordinate system NAD27 here, that is a continent-wide North American system. I'm going to look down under geodetic because it's a latitude-longitude system in the North America folder, and we'll see that entry there. If I drill down a little bit deeper, if I go down into, say, the United States, we'll find particular systems that are applying only to that slightly narrower area. Now, each of the coordinate systems and every parameter in the database is fully exposable. So you can see exactly all of the defining parameters that make up a datum, a transformation, a linear unit, all of the little bits and pieces that go into a geodetic system, or any type of system for that matter, really. We can right-click on those and select View Info. There's also an Info button over on the right-hand side, and either of those is going to bring up its definition. And the definition is a standardized viewer. These are accessible when you're either selecting a system or editing your own custom parameters. But each of these viewer panels has two tabs. There's an identification tab where you're going to find all sorts of reference information. You might find comments from things like the EPSG database. You might find identifiers that we can use to cross-reference these parameters across multiple databases. And then there's the definition panel. And the definition panel gives you all of the bits and pieces that make up that particular definition. So in this case, it's a geodetic system. Has very simple parameters, simply a point style, which is the type of units and the coordinate system rules about axes, the base datum, and an area of use. Now we're going to come back to that area of use in just a moment here. Any of those parameters can also be exposed. I'm not going to get too far afield with this because we have a lot to talk about today. But you can keep on breaking open these parameters to get right to the bottom of any definition that you find in the database here. So I'm going to select our system and come back to the main screen. Now you'll see that I've entered a coordinate for our input in this case. So a very simple coordinate. This is somewhere nearby where we are here in Maine. It's off in the woods somewhere. We're saying this coordinate, 44 degrees north, 70 degrees west longitude, is based on the NAD27 geographic coordinate system. And I'm going to transform that to, in this case, NAD83, a based system, a projected zone, UTM zone 19 north, with units of meters. I selected that out of the database, just like the latitude-longitude system. Now we have a need to relate these two systems because NAD27 is fundamentally different from NAD83. It's a different size and shape. It has its geocenter in a different place. So we need to select a coordinate transformation, or sometimes commonly known as a datum transformation, to get between those two coordinate systems. That's what the center box is for here, the coordinate transformation box. I already have one selected, but I'm going to double-click and activate so we can see what this does. And when I click on that, it's going to bring up the transformation selector. This is organized very much similarly to the coordinate system pickers, except this is showing us transformations based on the input data and the systems that we have for input and output. Now this is also going to bring us to one of the newer functions that we added in 2014. The map at the bottom of the screen there, if you're using an older version of the software, you're not going to have seen this map style before. All of the transformations and coordinate systems, all of these parameters are localized. So the common defining authorities, in most cases places like the EPSG database, define an area of use for each of these either systems or, in this case, datum transformations. So these are all very localized parameters, and if we select some of the different transformation options that we have available, it's going to show us exactly where those transformations are intended to be localized. The polygons that we see are a newer feature that's been added to the EPSG database, which is the sort of de facto world standard on these types of parameters, that was just added to these a couple of years ago in 2012. So all of these polygons are telling us exactly where these transformations happen to apply to our data. So in this case, it's showing me there are 4 different transformations that apply around that geographic point of my latitude and longitude that I entered. And we're going to use both the area of use where those are intended to be used, along with other tools such as the accuracy statement for each of these transformations. The polygon itself really only tells us exactly where this is intended to be used, but we have to take other steps involving things like the accuracy, which will be automatically sorted on to find the best transformation for our data. If we don't pick a good transformation for our data, if we were to pick this one underneath there, we can see its accuracy is it's actually made of 2 transformations. One is only accurate to 4 meters, the other is only accurate to 5 meters. And I could be introducing a fairly significant amount of error in my positions by picking a poor transformation. So the accuracy column is there for a very powerful reference to help you make sure that you're picking the best possible transformations for your data. Now the 4 that I have here happen to apply to different areas. The first 2 are continent-wide, or excuse me, countrywide here in the States. The third one narrows it down a little bit more localized to just the region of Maine where I happen to be. The fact that that polygon is tighter on the region where I happen to be doesn't imply anything about its accuracy. It's just telling me that that particular transformation set only extends to the bounds that we see on that map. The accuracy tag itself is used to determine what the overall accuracy is within that area. So there's a few different tools in here to help pick us the best transformation. So for this case, it's steering me towards this first transformation. If I want to know a little bit more about that, I can just right-click on it and say View Transformation. This is going to open up the definition of those transformation parameters. And in this case, it's showing me that this is using the NADCON transformation with a couple of particular grid files. And in this case, I know that this is the National Survey Standard for NAD27 to NAD83 transformations within the continental U.S. The identification tab will give us some extra things like remarks on that from the EPSG database, EPSG codes and such that I can use to cross-reference that into the EPSG database or other places to try and make sure that really is the transformation I'm after. Once we've selected that transformation, we just double-click it. It's going to return us back to the main screen. We can go ahead and finish off our calculation. So all we have to do is hit Calculate down at the bottom, and we'll see our output coordinates come out on the right-hand side of the interface. That is the sort of the basic workflow within the application. Everything beyond that simply gets a little bit more complicated as we apply different types of data. And so this is where some of those other jobs come in. We're going to take a quick look at some of these other interfaces. I'm just sort of going to quickly mention what some of these do, the types of conversion work they're used for, and then we're going to get into some of the newer features that have really been streamlined and upgraded in the 2014 release. So the point database conversion, this is sort of regarded as the workhorse of the application. Point database conversions along with seismic survey conversions beneath it both center around a table-based data set. So in the case of point database conversions, we're talking about formats like Excel, DBF, ASCII data sets like comma-separated files, tab-separated files, anything that is uniformly structured, tabular, either one of these table formats like Excel or an ASCII data format that we can parse out and load into the grid. There's a comprehensive set of tools for bringing in ASCII data. You can define your own text schemes, very complicated and powerful text scheme handling. And when I say very complicated, I mean we can bring in very complicated data with those tools. We define them as file types, and you don't have to do it every time you come into the application. Some of those tools are found under the Options menu. I'll just point you at the Text File Schemes menu if you're looking for that type of functionality. And then on point database conversions, this really comes down to the same types of conversion settings at the bottom. You'll see those common coordinate system tools, common coordinate transformation tools in the center, and it all comes down to the column settings. So with the column settings, this dialog is used to select which columns we're going to be converting. So if you think of a tabular data set, it's not like some of the vector file types or raster file types where you might only have one set of coordinates in there. You might actually have multiple sets of coordinates. So we use these drop downs to select from the headings. In this case, the headings are coming right from my data. We just need to identify what columns are going to be used in the conversion for both input and output. Once we have those, the data will simply allow us to make a conversion right here on screen. So in this case, we went from northings and eastings to latitudes and longitudes. And in this case, we did an operation on the same datum. So you'll see WGS84 on both sides, and we didn't need a transformation to go between those. So we don't always have to do a transform if we don't need one, but it's there if applicable. Now, another one of the new features that we added in 2014 was a little bit more powerful support for defining exactly where your data lives in the context of a point database conversion. You'll see on the lower right of my screen here that there's a little bounding box defined for this data set once it's loaded in. The way this works is once you load your data and you define where the column settings are, as soon as we have enough information to start recognizing where those coordinates are, in the background, the interface will scan the data set, figure out where it lives in the world, and then you can use that to isolate the particular transformations or output coordinate systems you're going to be interested in. There's not a lot of interface to show with this. It comes down to a new preference setting that you'll see, and that's going to be found under Options and Preferences. On the point database section of the preferences, there's a new set of preferences here for bounds, for where exactly how much of the data you're going to scan to get those bounds. Mine is currently set to retrieve the bounds from just the amount of data that I load into the grid. If you're fully loading your data, that's going to retrieve the bounds of everything. Or you can actually have it go scan the entire file if you're only doing a partial load. Scanning the entire file, you want to be a little careful with that if you're using very heavy data. If you're working with files that might have millions and millions of coordinates in them, it might take a second because it actually has to fully load that data, check all the rows, before it isolates exactly where it lives. So you can pick those various settings. And the first time you run through this in the 2014 version, you'll receive a prompt on where you would like to get the bounds from. You can always come back here in the preferences and set that as you wish. And then once the bounds are calculated, you'll simply see those right there on the lower right of the status bar on the point database conversions. The point database job can be used to write out any of the table types. It can also be used to write out vector file types. So you can spatialize your point data that you see here, spatialize it into vector-based files. The seismic survey conversion, I'm not going to spend a lot of time on this one because it's very similar to the point database conversion. It's simply an interface streamlined for those of you working with seismic data, things like SegP1, UCOA P190, SPS data, and also the new OGP P111 formats. This interface doesn't need very many settings. These are much more rigid structures of data, so we actually know where the northings and eastings and latitudes and longitudes live in your given file. There are some wizard tools here as well. Under Options, you'll see seismic survey formats that will allow you to load in and correct non-standard data. So there's some very powerful tools in here for cleaning up some of the seismic data, which does tend to be a little bit sloppy when you get into older legacy data that maybe was collected a long time ago and the formatting of it wasn't quite as clean as it should be. So a streamlined interface for these alternate types of tabular data. Vector data conversions, this is a rather simple interface. This supports about 20 different formats of vector data. I'm just going to pop up the list there so you can take a look at those. Everything from your common Esri shapes LiDAR data, map info formats, AutoCAD, MicroStation, KML, and so on. About 20 different formats, mix and match in between those, and these are also tied into our viewer. Just like the point database conversions are actually as well, I didn't mention it there. We can right-click on our data once it's been loaded in, and we can choose to open that into the viewer for quick inspection. There's a job for vector tiling. This allows us to cut up large data sets into smaller tiled grids. It's used sometimes for processing LiDAR data out into more manageable pieces. And lastly, raster transformations. The raster transformation job is based around a georeferencing tool. This allows us to handle either fresh orthophotos or scanned map data and apply a georeference to it. Once the georeference is applied, it's effectively just like any other type of data that we're going to handle. It comes down to the coordinates, and there are a number of tools for reprojecting rasters and applying compression to those formats. So those are the base types of jobs. And now we're just going to quickly run down through where some of the new features have come along in version 2014 for streamlining some of these various processes and how we get into all of these other types of specialty jobs that we see. So in my new in 2014 folder, this is a folder again that I've created with some predefined areas of use, and I have a job in here called vertical transformations. And vertical transformations is simply a interactive conversions job that I've set up some vertical coordinate system handling of. So you'll see down at the bottom, I have a vertical geoid model defined for input, in this case EGM 2008. And when I select that vertical coordinate system, it lights up an extra field called gravity-related height, and that's simply the point style label for that field. In this case, I've said this is at 0 meters, so this is right at 0 sea level according to the EGM 2008 model. And I'm going to transform this over to the North American vertical datum of 1988 height model. And to do this, you'll see my horizontal system is the same on both sides, and I selected that just simply for simplicity. What we're really focusing here on is the vertical transformations. And this is where it gets a little bit different. In the past releases in 2013 and prior, when you selected a vertical transformation, that had a particular geoid transformation attached to it. For those of you who are in the more technical ends of geodetics, the model was called early bound, and that means that the transformation was attached to the coordinate system itself. What we've moved to is what's called a late bound model, and this model aligns better with the EPSG standards and allows us to better match up to some of those parameters. So what's going to happen here when I go to select my coordinate transformation in the center? I'm going to now see a list of vertical transformations that are going to allow me to connect the dots between my input and my output systems here. So you'll see a number of transformations from EGM 2008 using various grids to various US geoid models. And all of these geoid models, all of those varying years that you'll see on the right-hand side of those, are different transformations. And the way this has been talked about for a long time is people have been saying that they're on a certain geoid from a certain year. And really, what you've got when you make a transformation in the vertical is that you are on a vertical datum on the output side, and that vertical datum is called the North American vertical datum of 1988 for this example. All of those various geoid models are just simply how you get there from an ellipsoid height in the middle. So what we have here now are recognition of two individual transformations being done. So if I were looking for one of the EGM grids, you'll see there's a 2.5 minute grid and a 1 minute grid. Those are different transformation standards. It has about the same data. One is simply a finer grid with a little more precision. We can pick which of those grids we're going to use and then match up with the particular year of geoid model for the North American vertical datum of 1988. For my purposes, I typically end up working with the 1 minute grid, and I'm typically using data that needs to be aligned with the 2012 geoid transformation. So I would pick that particular transformation right there. So EGM 2008 1-minute grid and the US geoid model of 2012A. Just like a horizontal transformation, I can just simply double-click on that. It's going to return me back to the main screen, and I can finish off my calculation, just like a normal interactive conversion.
If I could jump in with one quick question here. Someone has asked why there's been a change to the vertical coordinate system handling.
Okay, that's a completely fair question. It does seem like a bit of a change. There are definitely some name changes that have taken place in there. The reasons that we've done this, there's actually a few good reasons that we've done it. The early bound transformation model, where you pick your datum and your transformation in one go, it doesn't really scale very well when you have a number of different transformations to apply to a single vertical datum. Things get confusing pretty fast when you see a number of different things with the same vertical datum name, such as NavD88, as you'll see on my output there. EGM 2008 as well. Previously, that had two different definitions. One was the 1-minute grid, one was the 2.5-minute grid. And so you instantly start getting confusion when you're picking the system. The system itself is really one entity. It's the geoids that are actually transformation parameters to get there that are the things that vary. So that model is commonly accepted and is the base model that's used in the EPSG database. So in the EPSG database, there are vertical coordinate systems and then transformations between them in that late bound model. One of the major things that this change allows us to do is to completely align with the transformations and all of the systems that are found in the EPSG. So we're able to associate EPSG codes with all of our transformations and systems, and that allows folks to better match up their existing standards of things they need to work with. In the past, it just isn't really possible or practical to line up an EPSG code with a coordinate system that is really two things at once, a coordinate system and a transformation. It also allows us to apply extra area filtering tools that are a little bit more effective than the old model. So there's a few reasons for doing this. They mainly relate to scaling this up for the future as more geoids are introduced around the planet, being able to more easily update from the EPSG, and just being able to better define our systems similarly to those common standards, things like the ISO standard of EPSG and so on. I hope that answered your question. Feel free to follow up if you've got some more questions beyond that. Well, we've noticed a question about recording coming in. We do record all of these sessions. We are recording this session. It usually just takes us a few days to get those cleaned up and posted. So this will be right on our website pretty soon. So moving along with the vertical coordinate systems there. There's been a few changes under the data source menu to relate to that. For those of you using older versions of the software, you'll notice that my data source menu is actually shorter than it used to be, and that's not something that usually happens. But we've reorganized this to do a few different things. If we take a look under coordinate system definitions, first of all, you'll notice that there is now a vertical category, and this allows us to match up again to that EPSG model of vertical coordinate systems. So when we're selecting a vertical, what used to be called a vertical reference, we're now going to be looking for a vertical coordinate system in the data source. And as well, in the data source, we now have coordinate transformation definitions. And we used to have coordinate transformations as well as datum transformations. This, again, has also been aligned with the EPSG database. And under each of these subcategories, the vertical category has been added to single transformations. Datum and parametric have also been grouped under the single transformations as well. So when you're looking for those specific geoid models, you're really going to be looking for a vertical datum transformation now. Those used to be in the database under a heading called height models. So that's a slightly different place to look for those as well. Looks like we have a question coming in about what is shown in the coordinate transformation box about combinations of horizontal and vertical transformations. Very good question. Specifically, what's going to be in that coordinate transformation box in the middle, if you have both, is you'll see the horizontal transformations listed on the top, and you'll see these line breaks in between each of the individual transformations. So in this particular case, I only have a vertical, I have two vertical transformations. If I were doing something, let's see if I can make this happen more quick here. I will toss in NAD27 in there. If we, whoops, maybe something a little bit more compatible. Okay, well, what I'm hoping to show in there is that you'll see both a horizontal datum shift picker first, and then the vertical datum shift picker. Oh, I lost my vertical system. That's why. I'm not going to bother going through with all that. But if you have a horizontal transformation and a vertical transformation all in one go, what you're going to see is two pickers. First, you're going to see the horizontal datum transformation picker. And then instead of saying OK, the button will actually say Next, and it will take you to the panel to select a vertical transformation. Now, it is possible to select a concatenated transformation that does horizontal and vertical all in one step. Likewise, if you select one of those, you'll be able to select it at that first step, and then in that case, you would not see the second step of selection. But you will see all of those listed out on the coordinate transformation box in the center, and all of the parameters of those will be stored in any output reports that would come from that. So good question. Hope I answered that to your satisfaction. If you have any further questions on that, please feel free to follow up. Okay, so next up, we've added some significant new tools around those the polygons. I already took a quick look at those when we were selecting our interactive conversions. These polygons that we see attached to our transformations, they come up a few different ways. We can see them right here in the coordinate transformations when we're selecting those live on any of the interfaces. And we can also see those in the data source menu for any of the types that have a area of use defined for them. What I'm going to do here is just browse into a quick model here, and I'm going to open up a coordinate system. So the parameters of NAD27 here tells us where it's used in the world, so the normal area of use that we've seen. I'm going to open up that piece of information, and I'm going to go to the definition of the area of use. So you'll see the bounding box that has always been there. So typically the bounding box has been what you would see from 2013 to any prior release. The new function at the bottom of this is the View Polygon button. And when you click that button, it's going to bring up that basic world map, and it's going to show you the polygon that is sort of a clarified area of that bounding box. So it gives you just a quick reference of either where a particular coordinate system or transformation are used in the world when you're working with the definition itself. The third place that shows up is on our viewer. And I have a world countries base map simply loaded in there, and I'm actually zoomed into our home region here of Maine. And you'll notice there's a new toolbar button on the viewer. And the little GC button you'll see, that's a geocalc, and it's a little polygon. If you select that, you can grab onto any area of use in the database. So all of the areas of the use themselves, or you can pull the areas of use off of transformations or coordinate systems. So say for example here, I wanted to take a very quick look at where the Afghanistan envelope area of use surrounds on the map. We just simply apply that polygon, and we'll see that draw on top of our map. The only restriction there for viewing these is that your base data that you're loading in needs to be WGS84 based, since all of these polygons are WGS84 representations. So there's the third place the new polygons come in. Okay, and next up, we're going to take a look at a new tool that's fairly specific to the Calgary market, and this is what's called the Land Survey Summary tool. Now, those of you in the region of Alberta may be familiar with our handling of the Alberta Township System data. We've had support for that for a number of years now. Over the last few years, we had some user requests to make some automated map layouts in the contexts of the townships and ranges of the township system. And so what this ends up being is a new job. And so this is we called it the Land Survey Summary job because this will be scaling forward in the future to handle more systems than just the Alberta zones that it handles right now. What this is going to do for us is take, in this case, ATS data, Alberta Township System data, loaded in from an Excel sheet. And I have 4 simple points. And these points are essentially made up points in a particular region, modeling where a pipeline might be going across a couple of township boundaries. And these could be the output of the point database job, for example. Maybe you load in some latitudes and longitudes or projected coordinates and convert those over to ATS, and then you bring them over here to the Land Survey Summary job. At the bottom of this, there's only really a few settings around this. We have our ATS coordinate system picker. So you pick whichever zone you happen to be working in. And you'll notice when you fire this up for the first time, you're going to see a lot of these are going to be red entries with the little, the common exclamation point indicator, indicating that these need some additional grid files to allow them to function. Those grid files have recently changed a little bit. You can simply right-click on any of those definitions that you see in red, and you'll also have an option to automatically download any of the missing files for those entries. So probably the first time you run this, you're going to need to download those files, and then they will be instantly available for use. The one grid we are including out of the box is the current grid, the 4.1 grid. Any of the legacy grids are going to be available for download automatically right through this interface here.
If I could just jump in with one other question. Can ATS grids from version 2013 be used in Calculator 2014?
Okay, yeah, there are a lot of folks out there who have been using ATS with us for a number of years. And the way things worked in the past is you had to actually go get those ATS grids from another software vendor called Altalis up there in the Calgary region. The grids we were not able to distribute before, but that's since opened up. And we can now actually distribute those grids ourselves. And to do that a little bit more simply, we've actually restructured them. So the grids that you use in the calculator are identical in data to the old grids from prior versions. They are in a different structure. So the grids that you had previously downloaded for use in 2013, or if you have those grids for use in other software packages, those grids aren't going to be cross-compatible. But the good news is it is a very easy download. All you have to do is right-click on those to bring those in. To clean up the rest of the settings down here, we have our coordinate system picker, so you define which version of the township system you're working in. The report reference meridian that you're going to be working in, what UTM zone. We do some automatic conversions here based on your ATS input points. We'll take a look at that in just a second. The column settings on here simply allows you to define which column contains your ATS points. These column headers are coming in from the data that you load in. And there are some optional settings here on whether or not we're going to calculate the inverses between each of those points for this report. If we toggle that on, the points will be connected by a line, and it will also calculate for output the distance and azimuth between those points. So without getting a little too abstract here, I'm just going to go ahead and actually process this report. The final piece here is the little info panel. You can simply fill out your report information there, and I'll show you where that pops up on the main layout. So I'm going to go ahead and process that report, and we're going to move over to the output preview. One of the new features some folks saw mentioned in our service pack release was enhanced visualization on the land survey summary job. And real quick, what that is basically, as you were looking at this on screen, some of the coordinates as you zoomed in and out, we had a little draw issue with some of those, and some of them would be cut off visually as you zoomed in and out to different levels. That has been completely cleaned up, so you should be able to see all of the coordinate information calculated for each of those waypoints at all times now when you're viewing this on screen. Over there in the lower left, that's where the information is printed out. So this is designed to be a print layout. The scale, you'll notice a lot of folks have been asking about the scale being blank on screen. The scale will actually be filled in when you write this out to a PDF and you give it a paper size. So this actually comes out with a cartographic scale on paper when you complete that report. So the information that's automatically calculated are the latitudes and longitudes from that input ATS point, the northing and easting in whatever UTM zone you've selected with that report, both in NAD 27 and NAD 83 if you've selected that, and then as well the local coordinates that are your ATS points in there. So either the corner or boundary specification, and there's also settings in there for the display order, whether or not you're going to be looking at the unique well identifier method or the standard survey method. Now, the other bits of information here, you'll see the connecting lines that are going between those points. Those are there because I toggled on that find inverses function. And so what that adds is the connecting lines on the drawing and the azimuth and distance information for those calculations. So this would be modeling out something like a pipeline connecting those points. If we don't toggle on to take the inverses of those, what we see is just the points themselves with their information panels and no connecting lines or this bearing and distance information. Now the order of the points in the table is how those dots are connected, so that's where that comes from. We had our start point, and it's labeled start of traverse because that is what's in my description field on my data layer itself. And then all of those names simply come along likewise from that description column. Now the last piece of this is there's a little button up there on the toolbar to export this out as a PDF file. This is intended to be a print layout. That was the common request we were getting from ATS users. So this will save out as a PDF with all the typical page formatting options that you might expect of a PDF. And that is actually going to pump out a geospatial PDF. So it will be georeferenced, and you can load that into any other tools for visualization, maintaining all of those readout that you see for each of the points.
I have one more question before you finish talking about the land survey summaries. Are these going to be supported for more than just Alberta?
Yeah, that's a very fair question as well. So if you pop open the coordinate systems for the report here, you'll notice that we do filter this down to just the Alberta systems. And I know users in Saskatchewan have been asking for the same thing since we added the ability to handle the Saskatchewan grids. And we've actually heard from other folks who we haven't implemented the grids from in places like Manitoba and British Columbia. We are working actively on the Manitoba grids for implementation, so those will be showing up in a future version. They are not yet presently supported. We are working also actively to get the grid data for British Columbia. These are not directly going to be able to drop in to the land survey summary job in this version. We are going to have to assimilate those. There are some grid differences in how they are handled, but we do have every intention of waking up those coordinate systems for use in these reports once we get the tweaking done that we need to do for those. So great question, and definitely keep an eye out for those in future versions. So that's about it for the land survey summary job. I'm going to move it down to the line intersection tool. This was a new tool that we added in 2014, and it was added as a sort of a sub-tool of the area calculation feature. This was a request that had been around for a few years, and finally got enough interest in it to create this tool. And what this does for us is it allows us to define two line segments using their four vertices. So start point and an end point for each of these line segments, and it calculates the intersection point of those two lines. That intersection point may be in the form of two lines that actually cross in between their vertices, so something like an X shape, or it will also project off of the ends of the lines, as long as you have two lines that are not parallel. So they can be either internal cross or external cross. It's a very simple interface. We basically punch in a start point and an end point, point 1 and point 2, you'll see for line 1 and line 2. In this case, I have just a couple points that are almost perpendicular, or rather segments that are almost perpendicular to each other. And I've defined that against WGS84 geodesic model. Geodetic model. So I'm going to be calculating out the geodesic line intersection for our points here. It's actually already calculated on screen. When you hit calculate, that will just simply fill in these latitude and longitude fields at the bottom. And you'll notice these don't actually follow the same latitude. On our point 1, you'll see I set that up to be a line following the parallel. So both of these are on the same latitude, but because we are following a geodesic path, that doesn't actually follow the parallel. So it's going to be very slightly less than 44 degrees north. In this case, the line intersection is external to both of those line segments. Like I mentioned, it's a very simple job here. We can compute these either in geodetic space, so in this case on WGS84, or we can compute these on a projected space as well.
What kind of lines is the line intersection tool using?
The type of line, I mentioned that this one would be a geodesic path. That's also known as a great circle path, or a little more colloquially as the crow flies. That's going to be our shortest distance between the 2 points, and that's specifically because I'm using a geodetic coordinate system. If we move this over to use a projected system, the calculation will be followed in grid space. So what's commonly known as a simple kind of a trig calculation. It's going to treat the projected space as Cartesian and follow the grid path to connect those lines. If we have gotten a little bit of interest in this since it's been promoted to being its own job recently in the service pack. If you have any particular requirements for a tool like this that you'd like to see for implementation, definitely let us know about it. We'd love to make this the most useful tool it can be, because right now it really is very simple, and we would love to hear some more specific use cases on how folks would like to interact with this. Lastly, the area calculation is our other new job. So the area calculation tool, for those of you using prior versions, this used to be found under the window menu. This has since been promoted to its own job. It has been enhanced to be able to take input from Excel sheets. You can actually open Excel sheets up right in here now. This used to be a manual entry job. If you are going to be loading in Excel sheet data, the one thing we need to do is you actually do need to match those columns. So you need to have your latitude, longitude, or easting and northing in the appropriate structure to be able to load those in. But really, this is simply a job now instead of being a modal tool that allows us to save this in the main interface. And the primary purpose of this tool, for those of you new to the application, is this allows us to define the path of the individual line segments as they connect around the polygon. The reason for that is over very large areas, when we start talking about things like natural resources lease areas, over very large distances, those different paths will actually contain different areas. So in the legal definitions of certain properties, things like mineral leases or offshore oil leases, or even in some case just simply cadastral property lines, The distances and the line types being followed need to be mixed and matched. Some would be geodesics, some would be run lines, some might be grid paths, depending on the legal definition. All of those different paths are going to contain different areas, and for areas where very high precision area calculation is needed, the basic area calculation tools that you might find in the viewer and in some typical GIS applications, those might not deliver exactly the precision that's needed with those fine-tuned line paths. Let's see here. We've got just a couple more things we're gonna mention here to wrap it up with. This latest version is incorporating EPSG version 8.3. We have tighter integration with EPSG entities than ever before. Over the last few years, we've added in things like concatenated transformations, many new datum shifts, and support for multiple concatenations in systems. Those are things that allow you to apply very complicated datum transformations in particular if you are working with custom data. The one last thing I'm going to mention here is something we actually have no interface to show because it is an interfaceless tool. We have added command line support to the application as well. Command line, specifically command line launching of the application with particular job files or workspaces. So this is going to enable users to either write their own job files from external applications and then fire them off in the calculator, or in the case of some users, if you just simply need to update a similar data set, you can use the calculator to save any of these particular jobs that you might be working on, and then that needs to be simply rerun over on a sequential scheduled interval. You can use this command line interface with Windows scheduling tools. A simple bat file will fire that off. And the exact syntax for that is all right in the help files under command line interface. So that's a very simple but very powerful new way to operate the geographic calculator. So that's going to wrap it up for the features we were hoping to show today. I'm going to just take a quick look at some of the questions that have come in. Oh, I'm getting a report that we have lost our sound feed. If anybody is familiar with the GoToMeeting interface, if you could use the Show Hands tool to let me know if you can still hear me, that would be much appreciated. Seeing a couple hands go up. Okay, I think we got our sound feedback. Not sure what the problem was there. So, like I mentioned before, I'm just going to wrap up with a couple of these questions in here. One came in about the Iowa coordinate systems. Do we support the new Iowa regional coordinate systems? I'm going to go out on a limb here, and I'm going to say we did add those in there, and I'm just going to try and navigate down there to see if we did add them in, and yes, it looks like those did make it in there. So you'll see all of those localized zones. We can crack any of those open to view their parameters. See that those are the new low distortion zones used all around Iowa. Let's see here. Another question on Excel spreadsheets. Are we planning to be able to open a specific sheet within a spreadsheet? That is sort of a known feature request that we have on our list, and we are doing what we can to get that in there. I can't make any promises, but we are actively exploring that for loading in some data as well. And hot on the heels of the Iowa systems, do we support the Oregon low distortion projections? I can tell you we do definitely support those. I added those definitions myself actually a couple years ago. So down under North America, United States, if we get into, looks like, yep, I'm in the projected folder. You'll find the Oregon folder, and all of those low distortion zones are right in there as well. Those have been in there for, I want to say, 2 or 3 years that we had those in there, because I specifically actually remember entering those in our old office, and we've been in the new place for more than 2 years now. So Oregon, Iowa, and as well the Wisconsin systems. If there's anybody looking for those, we've had a lot of those for several years now. The Iowa ones being the actual new systems. Let's see here. We've got a question coming in about the 2014 supporting the blend of military and civilian aviation charts into a single overlay. I believe that's a function that would be better handled probably over in our Global Mapper application. And you'll have to forgive me, I'm not entirely familiar with the two different charts. I'm a little familiar with the civilian aviation charts. If you're looking to do something like a transparency overlay between two different raster products, I'm imagining those are, that would be a function much better accomplished over in Global Mapper. I imagine you may have a follow-up question on that. I would encourage you to send in an email to our support team at geohelp@bluemarblegeo.com. If you have any specific examples you can share with us, we will probably be able to give you the best answer that way. And I think the last question we're going to take for today is there any plan to execute automatic file database updates when the user is connected to the internet instead of manually downloading the geoid files? I'm going to break that into two different pieces. We are actively working on some new mechanisms for better synchronization of the coordinate system database with EPSG standards. The EPSG database is sort of in the long term moving towards the online format from the old Access database. The online repository is updated much more frequently than the twice-a-year sync of their Access form. Here internally, we have been using the spring and fall updates to resynchronize the database locally. For the user synchronization, I can tell you we are actually exploring some new tools to make that a little bit easier to keep the forward synchronization for specifically the EPSG updates and for those users who actually have their own internal online registry for the EPSG database. That's something we're going to be releasing definitely within the next year. But at this point, we're still in sort of early technical exploration on that, so I can't really promise a particular release on that just yet. The second half of that, for manually downloading new geoid files, that process is likely to remain with our FTP site if there are geoid files that we have available. And actually, likewise with our horizontal transformations, those files are manual downloads with the right-click method. You just simply right-click on anything that's red. If we have it, it will start downloading from our FTP site. We don't have any automatic setting to just go get anything we've got. That is something that we have sort of kicked around the idea of a little bit. For the foreseeable future, we are probably going to leave that as a manual setting, since the user that needs everything is the rare user. If you are that rare user, we actually do have bundles of those on our FTP site, and we can direct you to a sort of a mass download. If you write into our support team, we can group those together for you and give you probably a simpler way to download them all at once rather than having to click everything. And I think that is going to be the last question we've got that I see coming in. I would like to say thank you to everyone for attending today. And be sure to tune in a couple weeks if you're a Global Mapper user, or if you're interested in what Global Mapper can do. That's going to be hosted by my colleague David McKittrick. It's going to be an introduction to scripting, some very, very powerful tools. I might actually suggest the gentleman asking about mashing up those two aviation chart types. If that's something you have a lot to do, you might actually be able to do something with Global Mapper scripting to accomplish that task. So it's in a couple of weeks, same time slot. As always, if you have any further questions, please feel free to send us an email at geohelp@bluemarblegeo.com. Thanks, Taya, for hosting today with me, and thank you all for attending.